So out of an abundance of optimism, does anyone have questions from homework?
Well, I have this one, but this is from the
What you
test.
got?
So this is from the test, and I just wanted to see.
Oh, okay. This one?
Yeah.
Oh yeah, that's exciting. Let's see.
So
That looks right.
right?
Yeah, that looks right.
Okay. Okay.
What does that say?
Cosecant
Okay.
squared.
Yeah, you got it. And then you got to bring x back.
That's what I did here.
Oh, I see.
Theta equals this.
Well, yeah, I
so
know.
then
I want to know what that
replaced
is.
it. Oh.
Remember, that's when you draw the triangle.
Yeah, that's what I did.
Okay.
That's how I got the.
You should be able to tell me what the
X over 4.
cotangent is then. Oh, okay.
That's why I got the.
But this guy.
Yeah. That's what I got. So I drew the triangle.
So what's the cotangent of your triangle? That's what you did here.
Oh
Yeah.
wait. Oh, okay.
'Cause
This
I don't
was
wanna see-
different. That was
Yeah,
different.
don't give me your
because I
answer
got
as
that
a
wrong.
problem I have to solve, because I've already solved all my problems I wanted to. At least all my math problems.
Okay.
Alright guys,
Cotangent.
anything else, homework stuff? Okay. So, what I wanna do tonight, I wanna review a little bit. I have got, we have to do this. Let's do this, bless you. So everybody should have this now. So the idea with the interval test is if the associated interval of the function inside your series, if that converges, your series converges. If that diverges, your series diverges. Okay. I like it. It's kind of based on a Riemann sum interpretation of finding the interval, which is why it's, if you make your width 1, it kind of becomes the sequence elements. So when you integrate like this, the answer you get to your interval, if it converges, that doesn't mean your series converges to that. The most your integration test can do is if it diverges, your series diverges. If your interval converges, your series converges. You have no idea what to, you just know it converges. You guys kind of with me? Do you guys remember that? This is like the last thing we did last time. We talked about the interval test.
A little bit.
Okay, so if you thought, well, at least in chapter 11, at least there's no integration. Sorry. So let's do this. I've got a worksheet I'm going to want you guys to work on. So let's do these together. Does everyone agree? Let's see if you guys are with me. Do you guys remember we actually did both of these already?
Ish. Yeah.
We did. And in fact, we did every power of n. Yes?
Yeah, that was.
Because what is the name of that test we have?
thing.
P-series.
Yeah.
So, those are really easy intervals to do, but can anyone tell me, for number 1, what is the value of P? How do you know that? Because that's what? That's the 1 is where? Good. 1 is the power on n, on the bottom, yes? You guys kind of with me? And what does it take in order for the series to converge? What's got to be true? P has to be greater than 1. So this P is not greater than 1. Therefore, this series diverges. I need you to understand. I need somebody to be as tripped out, or even like 100 as tripped out about what I'm about to say. If I made the power on the bottom 1.57 billion zeros, 1, you with me? 1.057 billion of those, 1. That would converge. Thanks, Sarah. I appreciate appreciate that. Theater did, I love it.
You're welcome.
So, I guess, so that always tripped me out. That's such a knife's edge. So number 3 is the most interesting problem in the early going here. So we'll get there. What about number 2, real quick? Could you do the integral test for number 2? Actually, let's do this. How do I do the integral test? Because we already know the answer. Because it's a p-series, yes? But what would the integral test look like for this? I'll get it started. Limit as t goes into infinity. Integral 1
to t.
So what if this was n equals 7? 7 to t. Okay, good. Yeah. 1 over x squared, yes? Yeah, so we have to do the associated function. And the integral of 1 over x squared is easy, yes?
-1/3.
I have no qualms saying that. Should not be offended I'm saying that because it has to be easy. What is the integral of 1 over x squared?
Negative x.
Yeah, negative 1 over x. So if I plug in a t and I plug in a 1, what happens when I do this limit? This goes to 0.
So then you're
The integral is 1. That doesn't mean shit about what my series sums to. What is it that's important? The integral came out to be a finite number. So the integral converged, therefore the series converges. And very quickly, if I would have integrated the first one, what's the integral of 1 over x? ln x. And what's the limit of ln x as I let x go to infinity? Infinity. So that's why, that one diverges. But we made a shortcut out of it because it really just depends on what the power is. Okay, how we all do? So let me really see if you guys, let me get you to the point where number 3 has the appropriate level of niftiness. Do you all agree that one of the most fundamental reasons why it makes sense number 2 converges is because all of its sequence elements besides the first one are smaller than those of number 1? Yes? And the whole idea here is a series could converge if all of the elements from the sequence it's built off of get out of their own way. It doesn't allow it to kind of like accumulate on top of itself. And that's why the 0.1 plus 0.01, that one I keep going back to, is so beautiful, because it literally is getting out of its own way. So it can't possibly accumulate like a little speedometer and go, not speedometer, but you know what I mean, the odometer. There it is, one of those motors. Okay. So you guys are with me. If I take 1 over n and I multiply the bottom by another n, that makes it converge, yes? Because now I have 1 over n squared. Does that make sense? If I take 1 over n and multiply the bottom by n to the 1/2, let me write down what I'm saying so you guys can follow. Everything I'm saying right now, by the way, is sort of extra in a sense, but the more you understand what I'm saying right now, the more everything's going to make sense. So if I have 1 over n, that diverges, yes? Yes. We all know this is 1 to infinity, so I'm not even going to write it. If I multiply the bottom by n to the 1/2, what does that become? N to the 3/2. P series, this would do what?
It would converge.
Converge. P is 3/2 greater than 1, it converges. You guys would. All you need is if it's 1 over n to a power, you just need the power to be bigger than 1. So if I multiply 1 over n, if I multiply the bottom by n to the 0.000000001, when I put these together, I get n to the 1.001, yes? And then P will be bigger than 1, it'll converge, yes? So, you guys with? Good, this is good. I like it, thank you. You made my day. So look here, then I'm like, okay. If I multiply the bottom by something extra, then I should be dividing by more. My elements get smaller, it feels like it should converge then, yes? You guys with me? Now obviously I'm setting you up for something. Natural log of n. Can you guys all draw natural log of n in front of you? So here it's insane, yes? But all of this is below 1. You with me? At 1, it's 0, and then what does it do after 1? Does it grow very fast? It grows just about the slowest amongst all the base functions. And what I mean by base function, they haven't been translated or blown amplitude different or whatever. Yes? Just the base functions. It grows the slowest. I have no idea if you're with me or not. What I'm trying to do right now is just kind of talk a little higher level about these problems. I could do the integral test and get an answer and move on, but I want to just take a second and really sit with it. 1 over n diverges. Does anyone remember, it's not the most important thing, but the name of the sum of 1 over n?
Harmonic.
Harmonic, okay. Just take the a off the harmonic, yes. Okay. So do you guys get the idea? I'm like, oh, if I just multiply the bottom by a little bit, and I mean a little bit. The last thing I did was multiply by n to the point, oh, that's a freaking little bit. So if I multiply by natural log of n, it feels like it should converge. So let's try to do the integral test. And you're all like, yeah, let's do it, Jeff. We know what you're trying to do. So how would I do the integral test? How would I actually write that fully to be compliant with math laws?
The limit is.
Yes, I need a limit as t goes to infinity. Integral from 1 to t. 1 over? No. X, natural log of x. And just really quickly, do you guys understand? I can't use n's, because then I have a dot, and a dot, and a dot, and what does the integral do? What's the geometric idea behind the integral? Finding the total area. And how much area is below a dot? 0, because there's no width. You guys with me? So I have to look at the associated real valued function. So I'm getting more shit, but still, okay. Let me stop for a minute. I don't know if you guys are really with me. Okay. So is that a hard integral to do? Because you see a function in there whose derivative's in there also, yes? Which means what's going to work? U sub. So when I see a function in there whose derivative is also in there, U sub, and then you go, oh, thank the gods. Right? It's not trig sub. It's not trig integral. It's not by parts. Okay. So what do I let U equal? Ln x, and then du is 1 over x dx. So then this becomes, well, I could change my limits if I felt like it. When x is 1, what's u? 0. When x is t, what's u? No, when x is t, what's u?
Natural log.
Natural log of t. Good. And then this becomes this is du, yes?
Yes.
And then this is 1 over u.
Yes.
So you see where this is going. So what's the integral of 1 over u? Ln u from, where to go? 0 to natural log of t. Oh, yeah, all right, Jeff. Let me do one little thing. I gotta be more careful. Does anyone see how if n is 1, this is actually infinite?
Yeah.
Okay. Make that a 2. Yes? I caught that on some other things. That's an easy thing to figure out. So I'm going to do this. So that becomes 2. I don't know if you guys see the problem I was about to hit.
0.
So now if x is 2, u is the natural log of 2. Is that cool? Okay. So if I plug those in, I get the limit as t goes to infinity of the natural log of t minus the natural log of 2, yes? And what happens to this as t goes to infinity? This goes to infinity, so this goes to infinity. So it still diverges.
Yeah.
Okay, good. Which is trippy. the natural log of n grows so slowly, it is effectively smaller than n to the point as many zeros as you want 1. Because when I multiply by it, it's not big enough to make the denominator big enough so it will actually converge. I don't know if that makes any sense to you guys, but. So, real quick, just remind you guys. If I have 1 over n, that diverges. If I multiply the bottom by n to the point 0, 1, converges, yes? But if I multiply the bottom by natural log of n, which do you all agree makes the bottom bigger?
Right.
But it makes the bottom so little bit bigger that it still diverges. That says a lot about how slowly the natural log of n grows. It grows stupid slow. Slower than n to the point as many frickin' zeros as you want to 1. That is tricky. I will stop now, I'm sorry. All of what I just said is an interesting little side note, but it's really nifty. You know, like just keep moving because it wasn't, okay. It didn't land, Jeff, all right, whatever. Okay. This one, real quick. We could integrate it, but what can we do instead? What is this? 1 over n to the
1/3.
1/3. So p is
Less than
1/3, which is less than 1. So this
Diverges.
Now number 5 is a tricky, not tricky. It's not hard, but it's a multi-level thing. I didn't give you what I would call the closed form. Do you guys see how number 4 is the closed form? If I write the terms with plus signs, I have to put dot, 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 so that's kind of like the open form. You guys see what I'm saying? So can you figure out how to rewrite 5 in closed form? Meaning in summation form. You got to figure out what an is, yes? So let's see. I'll help you out a little bit here. A1 is 1 over e. A2 is 2 over e to the 4th, yes? And then if you just look at the powers, the top is easy, yes? Is that cool for me to say? The top is just what? Plus n.
N.
What's going on with the powers of e on the bottom? Because what's the first power of e?
They're being squared.
Up here? 1. Yes. So when n is 1, that's 1. When n is 2, that's 2 squared. So that's 1 squared. So when n is 3, that's 3 squared. So what's an? Good. The top is n, and the bottom is
N over E
e to the
N
n
squared.
squared. Ha ha ha. Sorry. Did you bring? Yes, I did. Where's it? I don't know. So how do you set up the integral test? So let me find the paper that I definitely brought for myself. There it is. So there's an, yes? So now I can write the closed form of this. Where'd it go? N equals 1 to infinity. N over e to the n squared. Is that a p-series?
No.
Hell no. P-series ain't got nothing to do with e base, right? In fact, the power is n squared. It's not something to an n power, yes? So it doesn't fit into p-series. Now let me just ask you this though. Can somebody tell me, gut feeling, do you think this is going to converge or diverge? Why do you think it's going to, that's neat. Sure, but where is it? Where is the e part? So that's why it's going to converge. E to the n squared, do you guys think that grows kind of quickly? Grows stupid fast, yes? And the whole idea is, if the bottom grows really fast, it could overwhelm the top. Right? Okay, maybe. So the top is going to infinity, isn't it? But it's going 1, 2, 3. When n is 1, it's e, 2.7182, blah, blah, blah. When n is 2, that's e to the 4th, which is roughly what, Jeff? Take a guess, 50. When n is 3, it's e to the 9th. I'm not going to guess that, sorry. But it's stupid big. It's in between 2 to the 9th and 3 to the 9th, and both of those are freaking big. I don't know if you guys are with me. So, listen. It is not good enough to say,
Well, like you say in class, I can see the bottom is.
no, you have to actually do it, but it's good to see how can you guess, because some of the tests we're gonna do, you have to have an idea going in, do you think it's gonna converge, or do you think it's gonna diverge? Because what you do will change. So do you guys, does everybody really see why I think this is gonna converge? Because the bottom's getting so big so fast, my elements should get really tiny really fast. So it's not gonna add up to infinity, it's not gonna have enough stuff that overlaps. Okay. So let's see if I'm right. I don't know. I could be wrong. How do I write the associated interval?
Limit as t goes to infinity.
Yeah, x over e to the x squared.
So we can't do e to the x squared.
Does anyone see the u sub in here? Do you see a function in there whose derivative is in there also? And we don't care about numbers. We can make numbers do whatever we want to. We made them. Yeah, so if u is x squared, du is sort of.
Kind
Now we gotta be a little more careful, right? If u is x squared, du is 2x. So what am I missing? 2. So I better put a 1/2. Yeah. Now those of you, I'm not going to take the time to do this, but some of you guys solve for dx, but that u sub doesn't always work. But when you solve for dx, you think, oh, I can make it work. No, if you get mixtures of x and u, you can't do shit. The whole idea of u sub is get rid of all the x stuff, right? Make it a complete u integral. If you cannot do that, you cannot do u sub. But what I hate, and this is, there's some places I really disagree with my colleagues, solving for dx makes students think more things are doable with u sub. And you just sort of power through. There's an x in there, and you're just sort of like, well, it's just gonna come from the right. No, that doesn't make any sense. Are we in multivariable calculus yet?
No.
So can we handle an integral with more than one variable in it? No. So if I want to change my variable, I have to do a wholesale change. So it's not horrible to solve for dx. I see the logic in it, but it makes students think you can do. So if you do that and you have an x still in there, no. If you did everything right, u sub won't work. You got to go back. Okay, maybe. I don't know if this makes any sense. You guys know what I mean? I know some of you guys, you'll solve for dx here. You'll divide by 2x. And then you plug that shit in, and then here the x's cancel. But that wasn't really hard what I just did. And it's much better. You're not going to make that mistake. You can see directly if you don't have enough for du. Do I have enough for du? Yes. So this would become, what happens with my limits? When x is 1, u is 1. When x is t, u is t squared. And this is du, and this is 1 over e to the u. So let me write that as e to the negative u. Is that cool? So 2x dx is du. I brought the e to the u up, made it e to the negative u, and now integrating that kicks a lot of ass. Yes? Much ass kicked. What is the integral of e to the negative u?
E to the negative u divided by
E to the negative u divided by negative 1.
Oh.
Yes. You divide by the part that would be the chain rule because you want to kill it because it's not there. Okay. Sorry. Is everybody okay with this? You guys see that? This is why u sub is more flexible than biparts. I could not do this with biparts. I could not. Because I don't see x squared in my original at all. I don't see x squared in here at all. I see e to the x squared. U sub lets me go in, and then say u, I'm gonna make u, okay, then, but by part says, this chunk is u and this chunk is dv. So, do you guys see that? I don't see an x squared that would be there for by parts. Because I don't see x squared as a chunk of this. Each of the x squared is a chunk of this, yes? And x is a chunk of this. Well, actually, 1 over each of the x squared is a chunk of this. Okay, maybe. There's no way in hell I want to do by parts on this thing, though. Okay. So what's the next step here?
What's the thing?
Negative e to the negative t squared. Good, plus e to the negative 1. Cool. So what does this do as t gets really big? Good, because it's to a negative power, correct? So that piece goes to 0. It doesn't matter what the other thing actually does. It just matters that it's finite. So my integral did what? Converged. So my original series does what? Converges. So you could say this. Convergent. So sum n over e to the n squared converges. Okay, right? Since the integral converged, the original sum converges. Okay. So it shouldn't be too surprising in a calculus class. You cannot escape integration. Same thing with differentiation. That's coming back to here in a little bit. Okay. I'll talk about this next, but I don't want to throw that into your brain yet. Let me give you this. All right, so quick little review of geometric. Can somebody remind me of the base form of the geometric series? Kick-ass. And the base idea is I just keep multiplying by the same number, and that number is r, right? What's got to be true in order for this to converge? Do it again. You can't put a restriction on n because n is doing its thing. R has to be. Nope. Less than 1. Yeah. Now, notice P series, the power has to be greater than 1. Geometric, R has to be less than 1. So instead of memorizing it, why does that make sense? If I tell you I have a number, I'm going to keep multiplying it to itself. If I just told you that the first day, and I said, what do you think is happening? You would say it's getting bigger. But is that always true? 2, if I start with 2 and then multiply it by itself, will that get bigger? Yes, 2 times 2 times 2 is 2 to the power, yes? What about 1? If I start with 1 and multiply it by itself? 1, yes? What if I start with 0.9? 0.9 times 0.9 is 0.81, times 0.9 is 0.729. So anything between 0 and 1 is going to get smaller. And if it's negative, it's just going to alternate, but it's still going to get smaller. So it's going to be kind of like doing this thing, yes? You guys are all with me? You guys really get this? So, sure, you can memorize R has to be less than 1, but it's less memorization when you realize why it just makes sense. I want the number that I keep multiplying by to be between -1 and 1. Now, obviously, if R is 0, that's a dumb question. right?
What's the sum of 0?
So r is not going to be 0, but it's got to be between -1 and 1, because then when I multiply it, it does nothing but it gets smaller. Okay, so go for it. You can start with these if you want to, because that's like related to, I'll just tell you, that's related to integral test and p-series. Or you can start here, this is the geometric stuff, yes? Okay. I'll let you work by yourself for a little bit, and then I'll force you into...
Oh my gosh,
Oh.
The screen made us go insane. We ended up solving it.
That's what it sounds like over here.
You have joined me. You know you got the math when you go slightly insane, and you really got it when you go fully insane.
There's just numbers all over the wall.
When you get into mathematics, you either start crazy or you become crazy. So some of you guys are there, and some of you guys are getting okay.
You know the integrals are right when the numbers are all over the place.
Yeah, I want red lines going all over, and I want
I just did it in my head and wanted to write it down.
That's my favorite. So guys, everybody saw this, yes? This is fantastic news.
unfortunately.
You're welcome. And I don't say that facetiously. You want more grades. You want more grades. Okay. So, real quick. Just to kind of remind you guys. So my calc 1 students, and everybody actually, when I give you a function to integrate or take the derivative of, what do you do first? Simplify it if you can. Yes. When I give you a series, unless it's real like a p-series or if it's just a general series thing, what do you look for first? What do you apply first? The test for divergence. Yes? So I've said this to several groups, but if I have a series and the stuff inside, if the limit is not 0, say the limit of the stuff inside is 1/10. Yes? That means eventually it's basically 1/10. Do you guys agree with me? Whatever this function is, if the limit is 1/10, eventually it's basically 1/10. So then I'm adding 1/10 forever. Yes? And that's going to go to infinity. So what's the only way a series has a chance to converge is if the limit of the stuff inside is 0. Because then hopefully it's getting out of its own way fast enough. So what you're doing when I give you a series, if it's not geometric and you can see what R is, and it's not P series and you can see what P is, if it's just something that looks like number 2 or number 3, take the limit. Take the limit first. If the limit is not 0, you have a little celebration because you're done. If the limit is not 0, it doesn't have a chance. You put divergent, test for divergence, next. If the limit is 0, you go, shit, now I got to do something. Yes? You guys with me? So the biggest mistake I always get is somebody will do the limit is 0, therefore the series converges. Nope. The sequence converges. I have no idea if the series converges. Because you all know, what does sum of 1 over n do? What's the series sum of 1 over n? What's it do? Does it converge or diverge? Diverges, yes? P series, P equals 1, which is not greater than 1, so no good. Okay. But what's the limit as n goes to infinity of 1 over n? 0. But it doesn't converge. So it has to be 0 to have a chance. So if it isn't 0, you're done. So let's really quickly look, for example, just to put a pin on what I just said. Number 2. The second number 2. What's the limit of this?
3/5.
Yeah, it's 3/5, right? No work to do. It's same degree top and bottom. So it's the ratio of the coefficients. So what I'll have is somebody put underneath that convergent. And I'll say, if this question was about a sequence, hell yeah. But it ain't. Minus 50. No. You guys come with me? What does that tell me?
That you're adding 3/5.
That I'm adding 3/5 forever. So what do I put? Divergent And if you really want to make a tear come out, and I might ask you for this, I might ask you, well, I will ask you for reasons, you would put test for divergence. Or at the very least, put not equal to 0, yes? So that I know you know why you just did that. You with me? Without somebody like shooting stuff in the dark and like, let me take a limit, what the hell, why not? And then you so I'm like, I don't even know if you knew why you did that. So if you put not equal to 0, at least I'm like, okay, at least you know that's what you're looking for. You guys with me?
Yeah.
Now if the limit is 0, shit. Now we got work to do. Dang it. Alright, so let's back up. So my geometric. I started you off nice. Is it in the right form already?
Yeah.
Yes. So I know what A is. 1. What's R?
2/5.
And is R doing what it's supposed to do?
Yes.
Yes.
Which is doing what?
Being less than 1.
Being less than 1. Kick ass. Therefore, this series
Converges.
convergent. And I also asked you for the sum, right?
Mm-hmm.
And what's the formula for the sum?
A over 1 minus R.
We identified A, we identified R. So 1 minus 2/5 is 3/5. Then you
5/3.
5/3. Yeah. If you had time, you could plug a bunch of ends in, add up like the first 7 or something. You should see it starting to get closer to 5/3 if you have time on the test or whatever. Yes? Yes? Is everybody with me? Geometric series are so nice. Okay. I have no idea if it made sense when I showed you where that formula came from, but I showed you where that formula came from. We didn't just pull it out of our ass. It actually comes from applying the concepts. Okay, so what about this guy? This guy is not, well actually he's in the right form, isn't he? What's A? That doesn't really matter because what's R? Which is greater than 1, therefore this is divergent, and you're like, yay, Jeff, give me more of those. Which I understand. Now, number 3, even before you do anything, you can see what R is going to be, yes? What would R be?
5/6.
5/6. Can you see why somebody might erroneously think it's 15/6? Can I multiply 3 times 5?
You could,
Why-
but if it's
You could, but you get it wrong, so
If
that would be
it's
silly. It's like me
put
saying,
to
could
the
I say
plus
2 times 4 is 5? Yes, I could, but I'd be wrong. So here's why. How many 3's do I have?
1
How many 5's do I have?
and plus 1.
So I am not going to make n plus 1 15s with 1 3 and n plus 1 5's, correct? So if you want to, you just pull that 3 out of the way. It's up to you. Yes? Be really careful because that will change the answer totally. R of 5/6, what's this going to do? If R is 5/6, like you guys told me, and it is, what's this going to do? Converge or diverge? Converge. It's less than 1. If R is 15/6, you're going to think that this diverges, and you would be wrong because it's not 15/6. Okay. You stop for a minute. So don't, please your God, don't 3 divided by 6 and put a 2 on the bottom because you don't have enough 3's to do that. Okay. So what do I do to make this? Now 2 things. I'm going to do this 2 different ways. If I want to put this in the right form, which is basically what I've been telling everybody to do, but now I'm going to show you a different way to look at this. If I want to put this in the right form, how many 5's need to come out? 2. You guys see that? There's 1 extra 5 compared to the 6's, but then I have to take 1 more, so the power is n minus 1.
These 2 things.
So I need to take out 2 5's, yes?
So therefore the whole entire thing
And how many 6's do I need to take out?
So it's divergent.
Just 1.
'Cause it's
So if I take out a 6 and 2 5's, how many of each are left? And minus 1. Now, can you see what A is? It's whatever 3 times 25 divided by 6, yes?
25. over
12 and a
here.
half, I think. You can see what A is, you can see what R is, yes? Because you put it in the right form. Are you guys with me? So now you can do all the same stuff. Does this converge?
Yes.
We already answered that. I love it.
Yes.
R is 5/6, it's less than 1.
So you get 75.
So then what's S? It'll be A, 12.5, divided by 1 minus 5/6, So it'll be 25 times 3, so it'll be 75, I think.
Yes.
Yep.
Yeah. Okay. Look at Jeff go. Do you guys get that? So I kind of want to make things consistent, but now let me show you a different way you could approach this kind of problem so you don't have to pull out 5s and 6s and go slightly insane. Is everybody okay with this
That
part?
one makes sense.
Yes.
Absolutely.
Oh, okay. Do me this favor. How many more 5s are there than 6s? There's one extra 5, correct? So if I take one 5 out, then there will be like 5 over 6 to the n. They'll have n of both, correct? According to the form of geometric, what do I want the power to be? Not n, I want it to be n minus 1. So I've got to take one more 5 and one more 6, and then I'll have n minus 1 of each. Do you see that? Okay. Now the reason I want to show you this method first is because the logic we just employed to get here is going to be every now and again throughout this entire chapter, it's going to show up. So I want you to get practice for that. But let me just show you a different way to get this. A, by the way, generally is the first term. In fact, how do I get the first term from the sequence, from the series? I would plug a 1 in, yes? And what do I get when I plug a 1 in? 5, 6 to the
0.
So I get this number, correct? So A is just the first element. You with me? So when you look at this problem, some of you at least should be able to see R is going to be 5, 6. Yes? You can see it's going to be 5, 6. And you know that it's going to converge. A would just be what I get if I make n 1. So I can actually just figure that out. If I make n 1, isn't this 3 times 5 squared over 6? Isn't that exactly what we just got? Okay. A is the first element of series. That becomes really useful if n is not 1. If n is not 1, doing the n minus 1 thing is not going to do it for you anymore. You need the first term of the sequence. If n was 7, I want to plug a 7 in. Because putting it into what we consider to be the right form won't work because it's built off of n being 1. I don't know if you guys are with me or not. So more generally, A is the first element. So do you always have to pluck off so many 5s and so many 6s? No. Okay. Maybe. What about this guy?
It converges.
Why?
Because
How do I
if we
rewrite
write
this?
it would be 1 over n.
Yes,
to
it's a
8
negative
sevenths,
power.
And
So it's
P
n to the 8
is
sevenths.
greater than 1, so it converges.
Shabow! Is that cool? So again, we know P-series, we know geometric, we know interval test, we know test for divergence, we know 4 things. Yes. Okay. So number 3. The next thing we're gonna learn. Let me see if you guys are cool with this. All right, you can't do this, not yet. We're gonna do what I'm about to do in a more formal way. But right now, I can tell if this is gonna converge or diverge. When n gets really big, what part of this doesn't mean shit?
The top.
Real quick, Jeff, college student, very plastic life in grad school, meaning I had a lot of credit card debt, yes? Because I was too much doing research and not enough time for a job, so just to eat, I did, you guys with me? So if I found $1 on the road, that would be a big thing for me. You guys kind of follow? And some of you guys are like, oh, I've been there. I mean, I literally would sometimes scrape through the back of my car and see, oh, I got change, I can get some gas, and maybe I can get home, yay. Yes? I don't know if you guys have ever done that. It's really exciting. Just, exciting is the right word. So when I'm looking at this, when n gets really big, what if Bill Gates found $1? Would that change his life? Would that change his day? Would that change
Well,
his
the
moment?
one
Would he
doesn't matter.
even bend over to pick the damn thing up?
Yep.
Right? I might talk about Musk. Maybe he would because his company's tanking. But sorry. That statement shouldn't be political, but it is. But oh well, too bad. So you guys see when n gets really big, plus 1 doesn't mean shit. Are you guys with me?
Right.
So what I'm about to do is not good enough. But if I just want to get a feel for, does this look like it converges? That's n to the 1/4 over n to the 5/4, yes? Could you reduce that? Yeah, you kind of cancel an n to the 1/4 out. What's n to the 5/4 minus 1/4 in the power? Because you can kill a 1/4 power. It'd be n. So this is effectively 1 over n. Do you see that? When n gets really stupid big, if n is 18 trillion to the billionth power, does that do anything? Nope. So it effectively is 1 over n. So I already know what is this going to do. I know it's going to diverge, don't I? So now I can do one of two things. I could do the interval test, which is what I pushed most of you guys to do because I'm evil. Now, can you see though the limit might be a little weird? So maybe we should do the interval test. Okay. So let's see. What would the interval test look like?
2 to infinity.
So it'd be 2 to, for some reason I made this 2. I'm not really sure why. 2 to infinity. I'm sorry, 2 to t. There we go, that's easy to fix. My t's got like a poofy shirt on or something. I don't know. X to the 1/4 over x to the 5/4 plus 1 dx. Can you guys, what do you always rule out when I give you an interval? U sub. If we make u equal to the bottom, which is the only thing that would make sense here, its derivative is effectively the top.
Plus some.
With some constants that we don't care, we can make those happen. Yes? So therefore, I know u sub will work. You guys see that? So if the series I give you is not a p-series, it's not a geometric, and I don't want to take the limit of it, that's when I do interval test. Yes? You guys kind of with me? And just to remind you guys, just to get us right, without the interval test, we wouldn't know the p-series test. Did you all agree the p-series one is one of the better ones? I don't know if you guys are there yet or not, but you're going to be like, yes, that kicks ass. Because it's very sleek. There's not much going on. I just got to look at the power and I'm done, yes? P-series kicks ass. So the interval test got us that, correct? With the stuff we learned in 11.4 and 11.5, we're barely ever going to have to use the interval test. We're going to learn some stuff where I can actually officially do this, but more formally. Yes? Because we already know the answer is this diverges. We just don't have a way to show it yet, so we have to do interval test. I don't know if you guys are with me or not. I just want to get you ready. We're going to leave interval test behind. So why did we learn it? Because without it, we wouldn't have p-series test, which is one of the best freaking tests there is. Yes? Okay. Plus, without it, as a math teacher, I wouldn't have an ability to make you do more intervals. That would be very sad for me. So what am I going to let u equal?
X to the 5/4
More than that.
plus 1.
Yes. du is 5/4 x to the...
1/4.
All right, you guys aren't going to help. Okay. Sarah's trying. So what do I need to introduce? Yeah, I need to put a 5/4 here, which means outside I need to put a 4/5, so that I just did nothing. Yes? Go, Jeff. So now I get the limit. T goes infinity. 4/5 integral. When x is 2, u is 2 to the 5/4 plus 1, which doesn't really matter.
Why is that on the top?
Sorry?
Why is that on the top?
I don't know because I wanted to. So 2 to the 5/4 plus 1. When x is t, this is t to the 5/4 plus 1, yes? And inside I've got 1 over u. D. So that's the natural log. Yes, 4/5. The constants almost don't matter because it really, all that matters is, does it go to infinity or not? Yes? So this is 2 to the 5/4 plus 1, t to the 5/4 plus 1. If I plug this in and I let t go to infinity, what is this going to do? Go to infinity. So this, like, so the integral diverges. So the series diverges. I don't know if you guys see what I mean. The integral test, if the answer is a constant, whatever that number is doesn't mean shit. It's just the fact that it isn't infinity. Does that make sense? The fact that it isn't infinity. So I can get to a point where I get all these freaky little constant numbers and I don't care. It's really just the t part. Does the t part keep it finite or does it make it infinite? Yes? So I am so cool with you sort of not doing the full integral because I don't need to. If you do that, that tells me you understand the point of this. The point is just, does the integral go to infinity or not? So do I care if it goes to 7 versus 8? I don't give a shit. I don't give a shit if it goes to 78 billion. That's not infinity. Okay. Maybe?
Could the test for divergence also work?
Hell yeah.
for this?
That was the first thing I said we could do. So you can just do the limit of the sequence and show that that's not 0.
No, like after you've gone through the limit and everything, you could also say, well, because it's infinity, which is not 0, so.
Oh, no.
Divergence.
Be really careful. If my answer for the integral was 0, then that's a convergent integral, so therefore my series would converge.
Yeah.
And by the
But
way, I
it's
think the
not
limit of
infinity.
this would be 0, by the way, so the limit test wouldn't work. You with me? Do you guys agree that the series diverged? Yes?
Yeah.
Do you guys see if I took the limit as n goes to infinity, isn't the bottom a higher degree? So won't that go to 0? So in this case, the test for divergence failed, which means, oh shit, I gotta do integral test. Okay. Alright. How do we feel about these problems? Are any of these problems still irking you? I feel like I'm doing some weird math Ouija board here. Oh, spirits. What will he put on the test? Okay, alright. There's nothing. Oh, go ahead.
Like, for the one we just did, like,
Yes.
how would you decide what tests to use?
Oh, okay. So that's going to become huge because at the moment we only have geometric, p-series, test for divergence, and interval test. Yes. Number 3 was not geometric. It was not p-series. The test for divergence fails, so the only thing I have left is interval test, right? Do you see what I mean? So, unfortunately, from one standpoint, we're going to learn other tests. So just like anything, when you guys learned all the derivative rules, what was the first test you had after that? Was just, here's a lot of functions, take a derivative, have fun. Where's chain rule? I don't know. You guys remember this?
Mm-hmm.
So of course, because what's one of the most fundamental things besides do you understand each process is do you know when to do which? That's the most important thing. And that of course is very often the hardest thing. So I'm going to try to point out, rule out this, rule out that, right? When you see an nth power, think geometric, can I make it look like something to the n minus 1? When you see n to a power, is it p-series? Yes? So you start to look for indicators in the problem, right? Okay. Maybe. I mean, that's the reality. I can't, I'm not going to try to sugarcoat that. That's the hard thing, right? We're in calculus too, so some of it's going to be difficult. Yes?
Would the integral test ever fail?
No, it's
Not for this one particularly, but just like in general.
one thing I don't think I made a big deal of, but I did put it on the handout, so I'm kind of glad you're asking this question, is the integral test cannot always be applied. Where did I put them? Yeah, damn it. I think I might have given them all away. Shoot. Does anyone have their little integral test handout? Just want to point this out.
This one.
Oh, here it is.
Yay, Jeff.
So, right here. This is a series with positive terms, right? F has to be decreasing and continuous. So I haven't made a big deal out of this, just because I wanted to focus on how this works. But in order for integral test to be applied, I have to have a series that has nothing but positive terms. It has to be decreasing, and it has to be continuous. Now, continuous makes sense because integrals over something that's not continuous, they're freaky. You guys kind of with me? So, in a sense, integral test cannot fail. It just sometimes can't be applied because it doesn't do what it needs to do. Okay. Last thing I want to talk about with integral test is the last little piece that's on the integral test paper, but I'm not going to put that up here. I'm going to try to show you why it's true. So if I have a function that meets the requirements, it's continuous, it's decreasing, and it's positive. All right. Yeah, okay, we'll do. So basically, if it's continuous, decreasing, and positive, I can kind of represent that like this. Is that cool? Now, one little thing in the background also, in order for this to be possibly convergent, it's got to converge to 0, doesn't it? Yes? Okay. If it didn't converge to 0, I wouldn't do the integral test. That would be done. Okay. If I have a series and I stop at the nth partial sum, yes? Can somebody tell me, if I stop at the nth partial sum, what's the first element that I've left off? So, what does nth partial sum mean? What was S1?
The first term.
A1. What's S2?
A1
plus A2. So if I go to Sn, what's the next sequence element that I haven't added in?
N plus 1.
An plus 1. Is everybody with me? Maybe? Maybe? Okay. So if I look at this, and I'm going to start at n plus 1, n plus 2. Okay. And if I look at the integral from n to infinity, and by the way, just to really make sure you guys are with me, that is the function that an uses, yes? It's like, I'm sorry, you guys can't see everything I'm writing. So if I stop at n, I'm curious, what is the integral from n to infinity, which should somehow be related to what I've left off. So I have added from 1 up to n, yes?
Mm-hmm.
And now if I integrate that, doesn't it feel like that should somehow be related to the amount I've left off? So if I have 1 plus a half plus a fourth plus whatever, and I add up to a certain point, I've left an infinite number of things off, correct? Now I'm curious, well, if I stop somewhere, how close to the actual answer am I? I want to have some kind of an estimate. What's the highest error? What's the highest amount off that I am? Does it make sense that I want to know that? You're like, I don't know, dude. Okay. Oh, there's my glasses. Oh, by the way, I want to check. Did they do? No. Okay. So bringing back, let me see if you guys are cool with this. If I bring back Riemann sum kind of stuff here, how wide is this rectangle?
N
No.
plus 1.
No. 1. What's n plus 1 minus n?
Oh.
1. So that is 1 wide, correct? Does that make sense? If I'm at n, I'm gonna go to n plus 1, I've went a step of 1, correct? How tall is it?
F of n.
Yeah, f of, now be careful, see how I did this side? F of n plus 1, yes? Okay. So isn't this a n plus 1?
Mm-hmm.
Okay. And this would be, I really want this to make sense. F of n plus 1 would give me a n plus 1. So if my series was 1 over n, and I want to use integral tests, wouldn't I make that 1 over x? And then I can integrate it, yes? You guys with me? F of x is just a n written with an x in it. So what's fn? A n. So what's fn plus 1? A n plus 1. What is the area of this rectangle? If the height is a n plus 1 and the width is 1, it's got an area of this, yes?
Mm-hmm.
What's the area of this next one?
an plus
A n
2.
plus 2. So these blocks, if I added the blocks up, that would be my sum. That would be the rest of my sum. Do you see that? That would be a n plus 1 plus a n plus 2, blah, 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 blah. The integral from n to infinity, if I did the integral, is my blocks, are they an under or an over estimate?
Under.
Good. Therefore, this would be greater than or equal to. I'm just realizing I haven't given you the notation yet. So go with me for a second. So you guys, what was S1, S2? What was that again? S1 is this first sum, yes. S2 would be the second partial sum. You with me? Okay. What was S? The whole thing, yes? So if I stop at Sn, this is S minus Sn. If I stop at Sn, I'm trying to figure out how far from the real sum have I gotten? How far from the real sum am I? Okay. And because math people are remarkably good at naming things, we call this a remainder, so we called it Rn. It's the remainder. It's how much I've left off. It's how much I would need to add to be a full sum. We could have called it En for error, but we're not that good. Now, there's a whole other argument for what the other side of this is. Like, I don't care about that. All I want is an uppermost, what's the most I'm off by if I stop at n, yes? So let's do one concrete example of this. And by the way, I think on the actual paper, I gave
It's on
you,
here.
yes, here. No, not this one. I just
It's the
had it.
first one, the one about integral test.
Yeah, here. Yeah, I gave you the other side, but most of the time we just care about what's the most I'm off by. So if you were gonna guess how much money somebody had, wouldn't you want to know the most you're off by instead of the least you're off by? So most of the time we want to be conservative. We really just focus on getting this. Okay, maybe. So I want to do a series that we can actually frickin' see what's going on, everything. So that very first problem from this handout was this guy. So real quick. Oh, that's, sure, why not, Jeff? We'll have fun with it. So let me write that down here. You guys we calculated S together earlier, yes? Was it 5/3?
Yeah.
Okay. Can somebody, real quick, what's the first element if I were to write this out? 1, yes? If I make n1, I get a 0 power. What's the next element? 2/5. You could do it. Just square these now. 4 25ths. Now raise it to the 3rd power. And by the way, for a math teacher, it's really neat to be near the 8 and the 125, which are both cube numbers. 2 cubed, 5 cubed. Whatever, you weirdo. All right. If I stop here, what is that officially? S?
3.
4. 1, 2, 3, 4. Yes? Okay. Do you all agree that if I add those up, I'm not going to get 5/3? Because I'm leaving a lot of stuff out. But do you see how small this one already is? So it kind of makes sense. I feel like I shouldn't be that far off. Now, the reason I'm doing this one specifically is geometric series, we know exactly how to get the full sum if it's convergent, yes? Most series we're going to work with, the most we can say is it converges. What's it converge to? We're not going to have a freaking clue. You guys understand? That's going to happen. So the question is going to be, is it convergent or inversion? I can't ask you what does it converge to. You're going to know. In fact, I'm going to show you a really cool, the sum of 1 over n squared. All right, I can't stop myself, sorry. Side note, sum of 1 over n squared. Does anyone know what that might be? It's pi squared over 6. Which is not obvious, yes? If I remember, I'm going to put that up in Canvas. I'm going to put the proof of this in Canvas because it's freaking cool as shit. And again, you don't have to be able to do it, yes? You don't have to even look at it ever. If I start to talk about it, you can go, no. It's fine. Okay. Most series, we don't have a way to get what they are by hand. We have no way. All right. So let's look theoretically first. Theoretically, R4. That is contained by the integral of 4 to infinity of this. X minus 1. Make that an X jump. There you go. Now this was a little gross, but we're gonna be okay. Gonna be okay. What is the integral of like a to the x? What's the integral of a to the x? What's the derivative of a to the x?
A to the x natural log.
A to the x times natural log of a, which again is why e to the x is its own derivative, because natural log of e is 1. So what is the integral of a to the x? Since the integral is the inverse operation. A to the x
A to the x
divided by ln a, yes? So this is an integral we can totally do. So, how do I integrate this? And in fact, one little thing you could do, does anybody not like the x minus 1 power? I don't know if anybody doesn't like it. Alright, let's just leave it. So this is equal to 2/5 to the x minus 1 times,
Wouldn't it be over?
yeah, over. I was thinking about one thing you could do to make this not this. Over what? Natural log of 2/5. Yes. Okay. I like it. Evaluated from 4, and I'm being a little loose here, but I can bring my limit in there. Real quick, can you guys see? I'll get 2/5 to the t minus 1 over natural log of 2/5 minus 2/5 cubed. Yes, want to put a 4 in? Divided by natural log of 2/5. Do you guys see what happens when I let t go to infinity? This is the fundamental idea behind a geometric series. What is 2/5 to the t minus 1 as t goes to infinity? You can do it. You can do it. 2/5 times 2/5 is much smaller. Times 2/5 is even smaller. Times 2/5 is even smaller. So what is 2/5 to the t minus 1 letting t go to infinity? 0. That's the whole idea behind a geometric series, right? So this first thing is 0. Can somebody help me out? This would be 8 over 125 divided by natural log of 2/5. Can somebody do that in the calculator? Do I have a calculator? I don't know. I do. You gotta be careful with your what do you call it? Parenthesize.
-1.2397 1.781175. Oh wait, why did I? No.
I don't know.
Sorry, I'm sorry. No, that's not it.
Anybody else trying it? Anybody else trying it?
Sorry, 0.0698468267.
Keep going.
What?
No, I'm joking. Alright, so I was just making sure that I was putting in there right. So negative 8 1/25ths divided by natural log of 2/5, I get 0.0698, blah, blah, blah. Yes?
Mhm.
Now, real quick. The total sum is 5/3, yes? Stay with me now, we're almost there. What is 1 plus 2/5 plus 4 25ths plus 8 25ths? Let's just do this here. 1 plus 2/5 plus 4 25ths plus 8 1/25ths. We get 1.624. And so what's 5/3 minus 1.624? So we're actually about 0.0426. So that is an upper bound. Let me see if you guys are really with me. That is an upper bound theoretically as to how far away I am from the real sum if I stop at the fourth partial sum. We're actually this far away. Is it less than this? Yes. So this is a theoretical maximum amount that I am off by. That's what it does for me. So I know I'm at most that much off. So if I'm like machining something and I do this, is that within my tolerance? If so, then I'm good to go. If not, then I might want to be more careful. Okay, maybe. Potentially. So just to point out a couple things, next time we'll get into 11.4. Alternating series. Actually, I think alternating series is 11.5. And this is 11.4 back here, but you know, I'm not good with numbers. So if you want to read over that, you can. If not, don't worry, we're going to talk about it next time. That's plenty. Do you guys agree? Do you guys concur? You concur, okay.